Sorry, we're a little bit late. Welcome to our virtual Speaking of Nature series. We're glad that you can join us tonight. So my name is Allie Esposito, and I am the Conservation Education Outreach Coordinator at Mueller Field Station. Mueller Field Station, for those of you who are unfamiliar with us, we are part of Finger Lakes Community College, and we are located at the south end of Honeoye Lake. And just a few announcements. Typically, we have a Speaking of Nature event every month. We will be having a June date. We just don't have that yet, so that's to be determined. If you follow us on Facebook or on Instagram, you can get the updates for that, and we highly encourage you to follow us. So we also have a YouTube channel where we put all of the recorded Speaking of Nature videos. So if you've missed any of them in the past, you can go check them out on our YouTube channel. Since we're a little behind, I'm going to jump right in. So joining us this evening is Dr. Bruce Gilman, and he's going to be talking to us about New York wildflowers tonight and unique plant communities. A little bit about Bruce. So he is recently retired from the Department of Environmental Conservation and Horticulture at Finger Lakes Community College, and he taught there for over 40 years. His teachings focused on aquatic ecology, field botany, glacial geology, agronomy, and environmental science. During his tenure at the college, Bruce was the director of the Environmental Studies program, and he was also the director of Mueller Field Station. So he has his PhD in ecology from SUNY ESF. He continues to curate the Finger Lakes Herbarium, a collection of over 18,000 plant specimens representative of Western New York. And he is preparing an updated edition of the 1983 publication, Ontario County Flora. So let's see a little bit more about him. He received the Friend of the Lake Award for his Canandaigua Lake research. He also received the Friend of the Land Award for his volunteer efforts with the Nature Conservancy and the Lake Tier of the Clouds Award to recognize his studies in several New York State lakes. Bruce resides with his wife, Margot, in Middlesex, New York, and he keeps busy tending to their organic garden, small orchard, and large raspberry patch. And I'm lucky enough to have gotten some fresh rhubarb and some kale today from him, and I'm very grateful for that. Thank you, Bruce. So I will be keeping an eye on the question and answer and chat, and we can take some questions at the end. But I'm going to pass it over to Bruce now. All right.
Thank you, Allie. I'm going to move right into the slide program. I'd like to say hello to everyone. As Allie mentioned, I'm retired now from the college and did author the county flora. That's really been keeping me very busy during my retirement. And as you know, everyone must have a favorite plant. And as you can see, I have a favorite tree, the tulip tree. Allie mentioned some of my teaching experience. There are some additional classes that I taught as well. And you'll see elements from each of these classes showing up in my presentation tonight. That's me right there, second from the left. It's kind of hard to tell when we're all celebrating Floral Friday. And in terms of wildflowers, it's not really the conservation seminar class, but rather the dendrology and field botany class, which really is where I concentrated in sharing with my students some of my knowledge about the native flora in this region. I did serve as director of the field station here for over a decade. And when the opportunity allows, I would encourage all of you to come down once we get through the pandemic issues and concerns. Please check with Allie. She's our principal educator down here at the field station. But there are many things you can find in this area that are rather unique. We have a wonderful bluebird trail, We have soft-shelled turtles in the lake. We have coal skinks in a nearby gully. And of course, we have beautiful wildflowers and lots of things going on, possibly going on here at the field station. I'd like to acknowledge some of the people that have helped, in my mind, helped me put together the program tonight. I'd first like to thank the Great Ice Age. It was responsible for creating this wonderfully diverse landscape that we have, and you'll hear more about that in just a moment. My parents at an early age, it may have been intentional, it was like, head outside, we'll see you at dinner time. And it allowed me to spend a lot of time with nature as a young child and really instilled an interest in all aspects of nature. My family today, my two daughters, my wife, they tolerate this creativity and imagination that started when I was a youngster. I had very good botany professors when I was in college, and I'd like to recognize Dr. Wentland and Dr. Faust and Dr. Leopold and Dr. Burgess for their really building my background in botany and in the identification of native plants. So tonight we're going to be starting with a small chapter called An Icy Beginning, just to make sure we're on the same page in terms of why the landscape is so diverse. It kind of lays the foundation for tonight's program. And then we'll talk about the return of plant life to New York State. Because 12,000 years ago, there was no plant life here in New York State, but more on that in just a moment. We're going to look at New York's biodiversity among all the different species groups, and then, of course, focus on the biodiversity of plants. This will begin by looking at the modern way we classify natural plant communities, and then plant species of special concern that belong to some of these unique natural communities. And I'll conclude by sharing with you some of the wonderful flowering plants to be expected, perhaps this spring, this summer, and this fall. It's all part of the current growing season. As Ellie mentioned, please use the chat box if you have any questions, and we'll get to those at the end of the program tonight. So the first chapter, An Icy Beginning. If we could travel back in time 20,000 years ago, we would see a very, very different landscape. Our terrain would have been covered by slowly moving ice. The temperatures here were 7 to 14 degrees Celsius cooler than they are today. The summer growing season, when melt occurred, would have been very brief. And this landscape was covered by nearly a mile-thick ice sheet, centered in Hudson Bay and moving outward in all directions, including south across Lake Ontario, that large basin, and spilling into the Finger Lakes region. This was a time period we call the Great Ice Age, and there were 5 continental ice sheets covering the planet during the Great Ice Age. Today, our planet has about 10% continental coverage by glacial ice. During the Great Ice Age, nearly a third of the land surfaces of our planet were covered by glacial ice sheets. If we look at our situation from this image of North America, you can see that there is an ice cap on the island of Greenland. There are small mountain glaciers that barely come into view in Alaska and the Canadian Rockies. And that's our situation today. But if we travel back in time to 20,000 years ago, here's this large Laurentide ice sheet that covered a good portion of eastern North America, again, centered over Hudson Bay and moving out in all directions. There also were significantly larger glaciers in the American, Canadian, and Alaskan coastal ranges, coastal mountain ranges, and they show up on this image as well. Not only was the land covered, as you see from above, but you also want to think about the fact that this was a massive weight resting on the landscape, and it would have depressed the landscape. And with the focus on that image that slid in from the right, that's the island of Greenland. And you notice that the thicker ice depresses the landscape in that small schematic in the upper portion of that Greenland island image. So it's heavy, weighting down on the landscape and of course spreading across the surface of the landscape. So this Laurentide spread out in all directions. So that meant it moved from north to south across New York State. What's important about this movement is the fact that the glacial ice had picked up a lot of debris. The bottom of the ice was dirty. It was embedded. There were dirty rock tools embedded in the ice, and they were agents of erosion on the underlying landscape. And then subsequently, when the ice sheet waned from this landscape, when the margin melted away, much of that sediment load was left as glacial deposits of various types. So you're all familiar with these NASA images of the Finger Lakes region. You can count from west to east, the 13 Finger Lakes. And there's a couple of cultural reference points in there, the city of Rochester, city of Syracuse, and the city of Ithaca, just so you can orient yourself. This landscape prior to the Ice Age was a rather flat, almost plateau-like landscape that geologists refer to as a peanut plain. And hundreds of thousands of years of rainfall on this plateau-like landscape inscribed a drainage pattern on the landscape. So I'll bring in this first one with these dark blue lines. It's over today in the area where we would find Cortland, New York. And the dendritic drainage pattern is one that has this forking pattern of side tributaries feeding into a main stem. If you look in the lower right-hand corner near Marathon, New York, you'll see that there's a second drainage pattern that was there prior to the beginning of this great ice age. We're going to zoom out now and take a look at it from a little bit broader perspective. So here's a nice digital elevation model with these various color shades that you see. Some reference points, Cortland with the capital C, Ithaca with the I, Binghamton with the B, and so on. Here's the blue pattern that I showed you previously over near Cortland, New York. And remember, there was a little bit of a purple pattern, so we'll bring that in. So that blue dendritic drainage pattern prior to the Ice Age moved in a southwesterly direction and then turned to the north in a valley where Cayuga Lake is located today and drained up into the Ontario Basin, which was probably no more than a river in that Ontario Basin at this geologic time period. That purple drainage pattern was more extensive, and it moved up through what today would be the Seneca Valley and went into that great Ontario River that was located in the Ontario Basin. And let's make it a bit more complicated. We'll bring in a green dendritic drainage pattern. And this one was here in the Canandaigua Valley area, in the Honeoye Valley area. And it eventually collected into a main stem that flowed northward, entering the Ontario River, probably in a mouth where Irondequoit Bay is located today. But this was all prior to the Ice Age. So let's see what happens when we get an Ice Age in here. So we'll bring in that ice sheet, Rochester, Syracuse, Geneseo, the capital letters that are indicated there. They're all under ice at this point. You can see the leading margin of the advancing ice sheet in the lower half of this schematic drawing. So this is starting at the beginning of the Wisconsin stage of the Great Ice Age, probably 70,000 years ago, the ice sheet gradually moving down slowly into New York State and then approaching eventually the Pennsylvania border. Now, as it moves southward, of course, there's higher land south of today what we think of as the Lake Ontario Plain. And so any pre-existing stream valley would have been flooded by meltwater along the margin of this advancing ice sheet. So certainly there were a series of flooded valleys in front of this advancing ice. And this created what are known as proglacial lakes. So today I mentioned we have 11 Finger Lakes. Well, there were probably close to 50 to 100 proglacial lakes in all of these high elevation valleys as the ice sheet slowly made its way southward. And all of these proglacial lakes had to have drained southward over some of the higher land down near our border with Pennsylvania. There was no way they could possibly drain to the north. All of that was clogged by glacial ice. Eventually, these small drainages for these proglacial lakes would have merged together and ultimately would have drained through an ancestral Susquehanna River system down into Chesapeake Bay. But it wasn't long after that that the entire New York State in our region, the entire Finger Lakes region, was covered by a massive ice sheet approaching 1 mile in thickness. So we've got our whole landscape here now toned in white to represent this massive expanding ice sheet. Now, as the ice flowed, it did selectively deepen any pre-existing valleys that were there prior to the ice movement. And these valleys that were oriented north and south, indicated by the arrows that I've indicated here, were the ones that were preferentially deeply eroded. In fact, we often say that these valleys were over-deepened relative to the rest of the landscape. And if you count those white arrows that are present on this image, you'll note that there are 11 of them. And I hope there's 11, 1, 2, 3, 4, 5, 6, 7, 8, and 11, yes. And they represent the major valleys that were over-deepened that would subsequently become our modern Finger Lakes. Now, beginning about 18 to 20,000 years ago, the ice began to retreat from the landscape. But during that retreat, there was a temporary pause, and some glaciologists of this region suggest not only a temporary pause, but maybe a slight readvance of the ice margin. And this readvance is called the Valley Heads readvance because it left very significant deposits in the south ends of these over-deepened Finger Lake valleys. For example, at the south end of Canandaigua Lake, the Valley Heads deposit is about 600 feet in depth. And down in Watkins Glen area or the Ithaca area, that Valley Heads moraine deposit is thought to be well over 800 feet in thickness. This Valley Heads moraine created a new drainage divide. So I'll keep the purple drainages in here. That was kind of that pre-existing drainage we talked about a few slides back. But notice in the upper half of the image, I haven't put a drainage system in, but we do want to note that there was a major drainage divide, and we established the Valley Heads moraine is that great divide. And we find if we're north of that, that everything will now drain into the Ontario Basin through the St. Lawrence Seaway to the ocean. But everything to the south still drains ultimately through the Susquehanna Basin and into Chesapeake Bay. And now we'll look at Canandaigua Lake from airplane flyover. We're positioned close to the Valley Heads moraine and looking north up the valley. So you can see the over-deepened valley now occupied by Canandaigua Lake. Off the image to the right would be the Valley Heads deposit just south of Naples. And there's another small moraine at the north end of Canandaigua Lake, which we located north of the city of Canandaigua, up near Sand Hill Road, an appropriate name for the nature and texture of that moraine deposit. So we have a valley valleys that are dammed at the south end and dammed at the north end, and they hold water in between those. These doubly dammed valleys become our Finger Lakes. If you climb up the top of Cleveland Hill at the Cutler Boy Scout Reservation and look to the south, you see the remnants of that Appalachian Plateau, and you'd see the broad U-shaped valleys that were the product of the advancing ice sheet in this area thousands of years ago. At the end of the Ice Age, that plateau quickly began to form new stream patterns. So we'll find these youthful, narrow streams, maybe meandering across ever-widening floodplains and beginning to create a diversity of habitats, stream channels, elevated stream terraces with wetland vegetation surrounded by upland sites of various elevations. And where some of these newly forming streams would retrace their course down into these over-deepened valleys, we would begin to see ravines forming. This concentration of water was highly erosive. The shale beds that are part of the old geologic formation here are fairly weak, and water and frost action would develop a series of beautiful gorges. We have a lot of microhabitats here. We have waterfall splash zones. We have seepage areas where groundwater drains slowly through the shale layers into these ravines. And we have all sorts of loose talus slopes at the base of these shale walls that are down along the edge of the streams. A wonderful diversity of habitats for a great variety of plants. Now, at the end of the Ice Age, most of New York State would have been tundra-like vegetation. The retreating ice margin was up in the Ontario Basin, Lake Ontario Basin, still fairly frigid. Conditions in the Finger Lakes region and along the Lake Ontario plain. Soils were just beginning to form. Everything was coarse gravels and sands, very little organic matter. Limited vegetation, short growing seasons were present. So where was the plant life that we see today? Where was it before it had an opportunity to migrate through seed movement, animals, and wind dispersal back into New York State? This is the second part of the story tonight. So we know from a variety of studies that when the ice sheet covered our area here in New York State, ocean levels fell by about 300 feet. And there's a lot of land available south of the maximum ice margin. But if you were close to that ice margin, it would have been cold. It's that jack pine spruce fir forest that we might see on high mountain summits in the Adirondacks and up into northern central Canada. You notice that the mixed conifer hardwood forest that's so prevalent in the Finger Lakes region today is way down in the southeastern states at this time period of about 18,000 years ago. Florida is about 3 times wider as a peninsula than it is today. And there's a prominent ridge, a sand ridge across the higher summits of Florida. I have to chuckle, there aren't very many high summits in Florida, but we do have this wonderful ridge home to one of our companion field stations, Archibald Biological Station in Central Florida. Now, there are various locations for plants and animals, things like salamanders, things like bird life, and of course, plant life of various types. They could have sought refuge along the Atlantic coastal plain. There was a lot of coastal plain exposed as the oceans were substantially lower. Some of our mountainous species could have been in those high elevation areas of the Appalachian Mountains, Tennessee, Kentucky, Georgia, that were free of this glacial ice sheet at this time period. And another very important one, especially for the salamander populations and other amphibians, was this lower Mississippi River Valley area, great refuge during the Ice Age and a spot from which they could move back into New York State when this ice sheet eventually disappeared. So if we look at fossil pollen studies that have been conducted, we know about 15,000 years ago, as the ice sheet was leaving the region, spruce in the upper left was in the mid-Atlantic states. The darker green color represents where the highest concentrations of spruce pollen have been discovered, and the medium green color also substantial amounts of spruce. Sedges, which are one of our graminoid species, we commonly see in wet meadows. We're certainly in the Alaskan interior that was ice-free during the Great Ice Age, but also along that coastal plain area and that contact with the Atlantic Ocean. Pines were down in the southeastern coastal plain and up into the Piedmont area leading into the Appalachians. Beech was isolated in I look down in the lower left now. Beech was isolated in today what would be the Great Smoky Mountains. Oaks were very prevalent in sections of Georgia, Mississippi, a little bit of Tennessee, and down into Florida. And maples, there's not very much evidence for where they were. We suspect they were scattered in that hardwood forest area in the southeastern states. This animation will show beech moving from its refuge area and moving northward as the ice retreated. You can see the countdown, 4,000, 3,000, 2,000, 1,000, almost back. And there's our modern distribution of beech along the Great Lakes boundary. We'll play that animation one more time for you. Beech, of course, is one of our more common trees that actually didn't get back here to New York State till about 3,000 years ago. If we looked at this set of animations, forest patterns near the end of the Ice Age, that one on the left is the one I showed you previously. Then the ice sheet about 10,000 years ago, the image to the right. And you notice that the natural plant communities are shifting northward. So soils are developing from coarse glacial deposits, climate is ameliorated, and things are able to migrate back in 10,000 years ago. And we see evidence of this in studying the pollen remains we find in anaerobic soils. By 5,000 years ago, the image to the left, you can see that mixed hardwoods are nearly back to New York State. There's areas that are dominated by hardwoods and conifers all through the Great Lakes region. It's drying out over to the west, so we have prairies there. And there's a prairie peninsula extension from the Midwest along the lower Great Lakes. We call this the Prairie Peninsula. There's a hypothesis about how important that was for some of the biological life that we see in New York State today. More on that later when we talk about one of our unique natural plant communities. 2,000 years ago, it looks almost like what we have in our forest patterns in the landscape today. That's if you exclude all of the human uses that appear in the landscape, especially since post-European settlement in Eastern North America. So we would find these wonderful sloping Appalachian oak hickory forests, these beech maple forests on moderate fertile soils, fairly level sites, find a lot of conifer hardwood forests, and these wonderful deciduous swamps that we have such a great example of here at the Mueller Field Station, part of the Honeoye Inlet Wildlife Management Area. Let's now turn our attention to the third main theme, or the third chapter, assessing New York's biodiversity. And we could start with a very simple definition of biodiversity, just the variety of life we see in a certain landscape that we're studying or that we're interested in. The value of biodiversity has been fundamentally established over the last few decades. And it's been recognized that every plant species plays a role in maintaining this biodiversity. And there's certainly a wide range of interests in protecting even the rarest of plants, because we know when they are lost, those communities are prone to change, to collapse, to being invaded by species from other areas of the world. Biological diversity in a more cultural sense is thought of as the natural capital for our landscape. It provides us with so many benefits: clean air, clean water, recreational opportunities, and it urges all of us to be very good stewards and recognize we're responsible for maintaining a healthy landscape. We look specifically at New York State. The vascular plants, these are the monocots and dicots and the ferns and the conifers. About 3,600 species are known in New York State. That's an area that I try to specialize in, so that gives me a lot to worry about, how to recognize, how to identify, how to study that great number of species. The non-vascular plants captured some of the mosses and the liverworts and some other species. They're not as well studied, so we really don't have good data on how many species there may be. With all the interest in birds and a lot of the volunteer hobbyists and the bird atlases, we know that breeding species are very numerous in New York State. And the same is true with all the information we have on mammals and on fish and on reptiles and amphibians. When it gets to invertebrate species, aren't a lot of specialists in that category, in that particular species group. So again, insufficient data there for us. We do wrap all of these species together into natural communities, and we do recognize almost 250 natural community types in New York State. And I'll give you an example of that in just a moment here for the Honeoye watershed. So ferns, horsetails, and club mosses, if we break those out, maidenhair fern just being an example, we have about 115 species in that grouping. 31 species of conifers, native and naturalized in New York State. Just over 1,000 monocot vascular plant species, and just close to 2,500 dicot flowering plant species in New York State. So we'll focus here on the plant biodiversity in New York State. Let's talk about these natural communities, this group of nearly 250 natural communities that we find in New York State. I'm going to introduce you to the New York Natural Heritage Program. This was set up decades ago as a collaborative, cooperative program between the Nature Conservancy, the world's largest not-for-profit environmental organization, and our local state agency, the New York Department of Environmental Conservation. And they have established a protocol for classifying natural communities here in New York State. Initially, they look at aerial photography. Locally, we use images that are flown and taken annually by a company called Pictometry International. We'll look at some examples of their imagery in just a moment. From that, the natural heritage staff come out and do extensive field investigations. They've kind of done an initial assessment of how much diversity is in the landscape, but they want to check it out. They want to make sure that they've been correct in their interpretation of those aerial images. They update their files. All of this is computerized in a GIS system, so they update those and create a truth image of the landscape. And let's take a look at the Honeoye Lake watershed, because while Natural Heritage has done some work in our region, their focus has been on rare natural communities. I've had the good fortune to work with Ontario County and study all of the natural and cultural communities that are in a landscape. So outlined in the pictometry image to your left is the 35 square mile watershed for Honeoye Lake. And those little red boundaries that are there are some of the stream drainages, some of the subbasins within the larger watershed for Honeoye Lake. And there's a green rectangle that I kind of zoom into, and that's the image you see to your right. It's an aerial image, one of those pictometry images. And even you, anyone out there, could look at an image like that and say, oh, there's a field. Oh, there's a ravine. Oh, there's a square dark green patch. It's probably a conifer plantation. So indeed, that's what we do in our initial assessment of these air photos. And then we go out and do our field investigations. In this case, we would do that assessment. You can see some green lines now highlighting some blocks in the zoomed in aerial image on the right. And then we go out to check all that out, make any corrections that are necessary, assign a plant community type to that block, color code it, make these wonderful maps for the various towns and the various lake watershed groups that are interested in knowing what kind of landscape they have and how it protects the water quality in their lake. If we summarize the Honeoye Lake watershed, we'd recognize that there are a number of different community cover types that are corresponding to those colors you saw in that previous image. That would be, let's see if I can go back to that image. Yeah, that image that you see right there. So let me bring in just a summary chart. For the Honeoye Lake watershed, we know we have riverine systems here. We have lake systems. Those are technically referred to as lacustrine. We have palustrine. Those are the wetland systems. And of course, we have a watershed that's primarily terrestrial. Within those four major systems, there were 36 different natural plant community types. It gave us that wonderful collage of different color patterns you saw projected in a previous image. There also were linear features, the stream channels themselves, and often little point features, maybe a spring on a hillside or a vernal pool that was smaller than the mapping boundaries we were able to do. We had 5 natural communities that statewide are considered to be very significant. And that means that there are very few occurrences of those natural communities across New York State. So they're very special for us to see them in the Honeoye watershed. The lake itself is an unusual lake in terms of its polymictic. It mixes many, many times during the summer. Large floodplain forest, this 900-acre floodplain forest and silver maple ash swamp are significant. Along some of the ravines, we have unstable shale talus slopes, and they're significant. And at the base of the ravine, we have some raised terraces that have an unusually rich mesic forest dominated by sugar maple and American basswood. If we look at the biodiversity of the southern Honeoye Valley, this goes back to the time period when we first acquired the Mueller Field Station back in the year 2000. We asked our college president to fund a special one-time study to allow us to get some baseline data on the biodiversity of the southern Honeoye Valley, where we would be bringing students and teaching them about biodiversity, whether it be our college students or people like Allie introducing a lot of our K-12 students that visit the field station. You can see there's a significant number of species that are found here in the southern Honeoye Valley. Now, when we talk about these natural communities that are special, we find that they occur in some of the least disturbed areas. And that's where we find really what I think of as the most natural plant communities. These are areas that have extreme environmental conditions. Often they fluctuate wildly over one calendar year. These are also areas that were largely inaccessible during the European settlement time period. So what they looked like 300 years ago is what they still look like today. Or these may be locations that had no practical value to the early European settlers. Maybe they were too rocky. Maybe the rocky outcrops had deep crevices that would have been a hazard to grazing animals, and there certainly wasn't any soil where they could have grown crops in these areas. So these are the spots where we find the relatively natural existing communities and governed by natural conditions, not governed by human activities. And there are a lot of species of interest. I call them special concern species that fall in these natural communities. We're going to look first at some of the unique plants found in the Alpine Meadows of the Adirondack High Peaks. We also will look at some peat bogs and the adaptations plants have to survive the unusual environmental conditions in peat bogs. We will turn our attentions to plants of the rare Alvar landscape in Jefferson County, New York, up near the St. Lawrence Seaway, an area I'm very familiar with, an area where I conducted my doctoral field research. And we also will look at plants along Lake Ontario coastal dunes. We do have coastal dunes along Lake Ontario, but there aren't very many of them. And so the plants that grow in those special conditions have become special in New York State. But first to the Alpine Meadows. If you've climbed some of the high peaks in New York State, some of those 46 high peaks, you can see there I am. I'm an Adirondack 46er. I've been up all the high peaks at least twice, and I've been up many of them multiple times. And on some of the highest summits in the Adirondacks, you can find Alpine Meadows. Now here in the top of Seymour Mountain, there's no Alpine Meadow. It's just an alpine conifer forest. Early October was Columbus Day weekend. Everything was iced in up there. And in the background, if you squint and look way in the background, way back into the east, that's Whiteface Mountain. Now that does have some alpine meadow vegetation. It's above timberline. We find it on a number of the other high peaks, Marcian, Skylight, and a number of others will find this alpine meadow. In total, there are approximately 85 acres of alpine meadows in all of New York State. Remember, at one time, right at the close of the Ice Age, most of New York State would have been tundra vegetation. So we have these little relics, these little reminders of the past in the alpine meadows and the highest summits of the Adirondacks today. These areas tend to have high wind speeds, very short growing seasons, very cold temperatures during the winter months, and many of the plants have succeeded only by being dwarfed, only by having small stature or growing in a cushion growth form. So we find things in the alpine meadow like dwarf willow and Lapland rosebay. Very, very small. Plants on high, but not very tall. Sometimes in the wind shadows of exposed rocks in those alpine summits, we can find gentians, one of our beautiful blue flowers. And then on those exposed rocks, look for map lichen, colorful yellow and black frustose lichen, or maybe something that looks more leaf-like growing on those surfaces, like the smooth rock tripe. Other plants are more typical of what we would find in wetter, lower elevation communities, because those high summits have low rates of evaporation. They have high snowfall. Snow melt contributes to moist soils throughout the growing season. And many of the plants we see in low elevation bogs may also co-occur in some of these alpine meadows. So Labrador tea, bog bilberry, and Bartram shadbush, a dwarf shadbush, is found in those alpine meadows. If you want to learn more about these alpine meadows, I would highly recommend a book by a colleague of mine, Nancy Slack, and her co-author, Allison Bell. The first edition was in fact called 85 Acres, and their second edition you see illustrated here, the Adirondack Alpine Summits. And it's a field guide to the northern birds you would see in those summits, the mammals, some of the special plants from lichens and mosses to the flowering plants and those dwarf conifers and bog plants up on the summits. Now we're going to go down in elevation, and in this instance we're going to end up at the Lost Bog. You know, it took me a couple of years to find this, so it indeed was a lost bog in my mind, probably 4 or 5 years, but then I correctly navigated to it and found it, the Lost Bog in the Nature Conservancy's Lake Julia Preserve, northern Oneida County, up in Remsen, New York. It's typical of some of the bogs you find around the Tug Hill Plateau and perhaps even in some of the lower elevations of the Adirondack Mountains. You have a central bog pool. You have a floating mat that's encroaching on that, floating mat of sphagnum mosses. You have some of these low-growing bog shrubs. And then farther back from the edge of the water, you may have some plants that tolerate being in the acidic conditions produced by this peat moss, the sequestering of buffering compounds by the peat moss in that pool of water. These are plants that are in these frost pockets during the winter. They're much colder than the surrounding area. And one of the notable trees that we see on that floating bog mat is black spruce. This one stood about 4 feet in height, and though I didn't core this one to age it, I was in a protected landscape. I've read of other areas where they have been aged, and a small tree 5 foot high could easily be 200 years in age. Very poor acidic growing conditions, these water saturated soils. Back towards the edge of the bog, you may see an improvement in soil nutrition. And there you may see American larch rimming the outer edge of the bog leading into the terrestrial habitat. Larch is one of those funny conifers that drops its needles every year. So you watch for this one to turn golden yellow in the fall, as the maples and other trees are getting brilliant colors of yellow and gold and red and purples. One of the bog shrubs that I enjoy, I always try to visit some of these peat bogs during early to mid-July. It's highbush blueberry, because I know I can take a break there and enjoy the fruit that's produced by highbush blueberry. In fact, it's one of the parents for many of the blueberry bushes that have been hybridized that are available for your home gardening pleasure. Cranberries mat along the peat moss, creeping vine. Beautiful pink blossoms, small, but they're there early in the summer. And these fruits develop in October, and they're quite tart. I don't know if you've ever tried fresh cranberries. They're quite different than what you get out of opening a can for a Thanksgiving celebration. These are mouth-puckering, these fresh cranberry fruits. We have some plants that get their nutrition from insects rather than from the substrate, the peat that they grow in. And one of those is Sundew. It has wonderful blossoms you can see in that center image, but in the drawing to the left and the image there to the right, you'll notice that its leaves have been modified, and there are sticky glandular hairs that protrude from the margin, the outer edge of the leaves. And these hairs, when you zoom in on them through a microscope view, they are glandular hairs that actually secrete a digestive juice to break down insects that get stuck on those sticky hairs. Important for controlling insect populations. You can see the research in England, 6 million insects caught annually in a 2-acre bog. Our common sundew in this region is the round leaf sundew. Just zoomed in here on those sticky glandular hairs. There's actually a tactile response when an insect lands there. Neighboring hairs will close in on it and make sure that insect cannot escape and will be digested and used for the nutritional benefit of the plant. Another insectivorous plant of the bogs is the pitcher plant. Line drawing of its unusual features. The tubular leaf is kind of curled around and stitched together along a seam, open at the top. You can see in the drawing that there is a long stalk nodding flower that's produced from the basal rosette of these tubular leaves. And then an actual image of pitcher plants that I took up at the Massawepie Boy Scout Reservation in the Adirondacks. A nice clump of pitcher plants. So in these pitcher plants, the flower provides an important role. It provides a landing platform or a resting area for insects that perhaps been attracted to this plant by the odor emanating from that open tubular leaf. And it's a terrible odor. It's an odor of decaying meat. It actually mimics that odor very well. When you look at these leaves, think of them as a pitfall trap that someone would be using to study wildlife populations, where they would take an open can, bury it in the ground, put bait down in the bottom of the can, wait for the unknowing small mammal to come along and fall into the can and not be able to get out. Well, the pitcher plant is nature's pitfall trap. Got an opening at the top of the tube with downward pointed hairs. Notice that the coloration of the lip of that tube looks like meat with streaky fat layers moving through it, so deep red and some of these light yellowish green blotches. And of course, rainwater has collected down in the bottom of this open tube at the base of the pitfall trap. And in that rainwater, the plant has secreted some odor-producing chemicals and, of course, some digestive enzymes. The unfortunate insect lands perhaps on the flower, finds out the odor is coming from that open tube, lands on the lip of that leaf, begins to walk down. The downward pointing hairs don't bother it on its way down. And it finds that it's kind of a waxy surface on those leaves. It slips, falls into that pool of digestive water and enzymes, and it breaks down. If you slit open one leaf, which has been done here, you can see the exoskeletons of all of those digested insects that have been harvested by this leaf. And the leaf may be there for 2 or 3 years, used continually by the plant. Occasionally, you'll find a vertebrate down inside the leaves as well. A study in Connecticut actually found a red F salamander that accidentally fell into that tubular leaf and was digested by the plant. Now we're going to go to nature's rock garden, the Alvar landscape of northern New York up in Jefferson County. This is an area of massive limestone outcrop, the Chameau limestone formation. It covers most of the western half of Jefferson County, from Watertown all the way over to Lake Ontario and up nearly to the St. Lawrence Seaway. Most of the soil was swept off this area. Most of the glacial deposits were swept off this area by a catastrophic flood at the end of the Ice Age. The weight of the ice resting on this landscape cracked the underlying limestone, so it has a series of fissures or grikes, or what I simply refer to as limestone crevices. A birding friend of mine, Jerry Smith, he referred to these as Jerry holes because he was often walking through this landscape looking at some of the rare bird populations that occur here with his binoculars to his face and would accidentally step into one of these, hence calling it a Jerry hole. So in this limestone landscape, we have a series of plants that probably arrived here during the Prairie Peninsula expansion at the very end of the Ice Age. Because these thin soils are underlain by limestone, they have a very high pH, the opposite extreme of what we find in peat bogs. And our prairie soils also have a very high pH in the Midwestern prairie states. So we have in New York State an isolated geology that mimics prairie conditions. They're well-drained soils, they're thin soils, they're droughty soils, similar to the conditions you would find in the Midwest. And a notable plant that occurs there is Prairie Smoke. It flowers this time of the year, but by early June, its feathery appendages on the seeds have formed, giving that smoking appearance to this short plant, Prairie Smoke. It was first known from the Chameau Barrens Alvar landscape up in the town of Lyme, New York. Other alvar plants include the Indian paintbrush, a snapdragon that's known from the southern prairie states and in some of the Rocky Mountain prairie-like habitats. But it's found in Chaumont, New York at the Lucky Star Ranch alvar. And it's an interesting plant because to get the extra energy needed to produce flowers, it has to parasitize a prairie grass. So it's what we call a hemiparasite. It'll be able to live non-flowering without making that parasitic connection. But to get the energy to flower, it's got to make a root connection to that prairie grass. Often it's a rare prairie grass that also is found in these alvar habitats. Hey, look at that guy leading this alvar walk. Whoa, that was a few years ago. And I'm explaining this open alvar meadow. And one of the characteristic plants of this open alvar meadow is the sedge that the New York Natural Heritage Program has as an endangered species here in New York State, Carex crayi. We can find yellow lady slippers. They like these alkaline, these calcareous conditions. The study site that I was working in had over 3,000 yellow lady slippers when I did a population count for the New York Heritage Program in this one location. These are a beautiful orchid with a highly modified flower. There's a small opening underneath those twisty, curvy sepals. Pollinating insect enters that opening, can't turn around because of the tight quarters inside the pouch, and touches the stamen, the male reproductive organ inside the pouch, gets covered with pollen, and the insect exits a trapdoor on the bottom of the pouch and carries the pollen to the next lady slipper that it visits. But the rarest lady slipper of all on the alvar is this tiny one called the ram's head lady slipper. That entire pouch, that unusual ram's head shape, is only about 1/4 of an inch in size. It's found in some of the limestone cedar glades of the alvar plant community. Also on the alvar, we have the only known population of natively occurring wild chives in New York State. And in the limestone woodlands, another blue flower, a pretty one, called the wild blue phlox. One of the more significant indicator species of limestone rubble sites in the alvar is the balsam ragwort. And although it's quite numerous when you see it, there are limited populations, in fact, fewer than 20 populations in all of New York State. And the same is true of the golden corydalus on some of these limestone crevices. There are poisonous plants here, as there are in many landscapes of New York. This is the deadly Canis lily, and it grows to maybe 2 feet in height, blossoming this time of the year. These white petals with little green throats and the protruding stigma of the female reproductive structure from the throat of the flower. And there are wonderful mints up here too that are quite unusual, including the beautiful American dragonhead. We're going to go right over to Lake Ontario from the alvar, so we're going to travel west about 30 miles and maybe a little bit to the south, down below Stony Point Lighthouse area, Henderson Harbor area, and we'll find the beginning of 17 miles of sand dunes along the eastern shore of Lake Ontario, beginning in southern Jefferson County and extending down into northern Oswego County. Often these dunes approach 30 to 100 feet in height, and behind them are wonderful wetland plant communities, dune pond communities, sometimes broad expanses of wetland meadows, and silver maple ash swamp forests associated with the dune communities facing the Lake Ontario shoreline. When you look at the primary dune just in from the beach along Lake Ontario, you could imagine how this is a very unstable soil for plants to colonize. These sands are subjected to winds blowing across Lake Ontario and along Lake Ontario and moving inland here. These are highly disturbed soils by these wind conditions. So we find an odd combination of rare plants that tolerate these shifting sands growing among weeds that also tolerate areas that are subjected to high disturbances, the disturbances here being natural. The plant you see in the foreground is it's the Champlain beach grass, which was thought to be an Ice Age relic that occurs in the dunes and over along Lake Champlain. It's able to grow where its root systems get exposed, but it also is able to grow and regrow in areas where sand has buried it, and it'll continue to grow until it breaks through the surface of that recent sand burial. Sand dune willow is characteristic of the sand dune communities along Lake Ontario, and it's low growing. It has lots and lots of hairs along its leaf surface that help to capture moisture in the air, the early morning dew, and hang on to it, because otherwise there'd be high rates of evaporation in this windy environment. We have a low-growing cherry in these areas, the sand cherry, just a few feet in height, flowering, tolerating sand burial, tolerating exposed roots in these dune blowout regions. Now we'll finish the program by looking at some of the wonderful, beautiful wildflower plants that you could see this current growing season. Perhaps would have seen in nature walks within the last few weeks, or to be expected in the summer or in the fall. So let's look at this on the basis of natural communities. And we're going to start in a nice swamp forest, an area that I worked on in my bachelor's biology program, the 1,000-acre swamp up in Penfield, New York. Has a wonderful elevated boardwalk, so it allows you to get into the interior of the swamp and see it and stay dry at the same time. This swamp forest is in many areas dominated by cinnamon fern and royal fern and marsh fern, and these are best recognized right about this time of the year when their spore-bearing stalks are quite evident. Later in the year, in some of the swampy areas and sometimes along stream floodplains, you'll find the ostrich fern, and it's best recognized in the fall of the year because that's when its spore-bearing stalk is most evident. This is a tall fern, and it often grows with stinging nettles, so beware if you're looking at a population of ostrich fern, beware of what else might be growing there. Early in the season, in the swamp forest, the shrub layer flowers before the canopy trees leaf out. And we might find blossoms of spice bush, a very fragrant shrub, and Winterberry Holly, a New York State protected shrub. It's the female hollies that produce the shiny red fruits. Viburnums are quite common in the swamp forest communities of our region, and nannyberry viburnum and arrowwood viburnum are perhaps the two I would think about looking for. And black elderberry by midsummer has come into full bloom in these swamp forests. You might still find it with fruit, but certainly the birds feed on it very, very quickly. Early in the season, one of the plants black bears might utilize would be skunk cabbage, and it has a spade and spadix flower arrangement that's typical of the arum family. You can see it in the included photo in the lower right, a spike of flowers inside that kind of open cone-shaped spathe that kind of surrounds it, and then the skunk-like odor-producing cabbage-like leaves later in the year. Marsh marigold is prevalent in the spring in these swamp forest communities. See some images here, various close-up images and scenic images of the marsh marigold. rare plant that grows in these swamp forest communities, somewhat looking like marsh marigold, sometimes associated with it, is the spreading globe flower. It's an Ice Age relic because it prefers to grow on freshly deposited glacial moraines, gravelly, wet glacial deposits. We simply don't have those unless we can find a habitat where there is a moraine, now 10,000 years old, but it has a spring underneath it that upwells this cold water, washes away any finer soil particles, and just leaves the wet gravel and sand behind. Find that, and you might find the globe flower. Wild blue irises will be in bloom soon, along some of the streams that drain through our floodplain forests and our swamp forests. The Virginia bluebells, I always look for them in bloom during Mother's Day weekend, especially in Mertensia Park up in the town of Farmington. And cardinal flower by midsummer will be in bloom. We have lots of that here at the field station. Arrowleaf, Sagittaria, noted for its unusual shaped leaf, and pickerel weed, emerging from standing water of 2 or 3 feet deep, perhaps an area that pickerel use as a nursery early in the season for them. Probably need to be in a canoe or in waders to enjoy these wildflowers in some of the drainage channels of our swamp forests. Spotted touch-me-not, late summer, swamp milkweed, both are very good for pollinating insects in this area. Spotted Joe Pye weed, another one that the insects are certainly attracted to, the bees and the butterflies, and the unusual shaped white turtlehead blossom in the fall of the year in the swamp forests. Now we're going to look at some ravines. Remember, ravines have these shale talus slopes bordering the streams. They have outcrops above those slopes, and they have waterfalls, splash zones, and some of these secret small microhabitats. This is the Clark Scully Ravine Forest in Yates County, but there are many of them found throughout our region, and I trust many of you in the audience have hiked through these ravine forests. I look for Dutchman's Breeches early in the season, often with it the foam flower. There are 2 in these ravine forests. You can find the true miterwort, sometimes the foam flower is referred to as the false miterwort. So while their leaves are similar, their inflorescences, their flower clusters are distinctive. Our wild ginger prefers to grow in some of the shale talus at the bottom of the outcrop walls, and it's there too we may find red trillium in great abundance. Both of these are past bloom now, but of course the leaves would still be there and you could still recognize them based on their foliage. Now the successional hardwood forest, that's most of the forest in their area on these upland soils. They're dominated by a number of hardwood trees. Often beech makes it up to the canopy layer. They're the tallest trees in the forest. And sugar maple is very common just beneath them in the understory of the forest. But you may find black birch, you may find yellow birch, you may find basswood, and some of the rivulets that drain through the hardwood forest, and maybe some hemlock trees. You can find white pine in various areas. So it's a rather diverse forest with a number of different tree species in the upper layers of the forest. Down on the forest floor, we look for Christmas fern, an evergreen fern that's very easy to recognize here in this successional hardwood forest. You can find commonly the large flowered white trillium, a rather robust trillium, and it does fade to pink at the end of its bloom season. You'll notice that in the upper left-hand image. It too is affected by a mycoplasm-like organism, and if that's prevalent in the soil, you may find some white trilliums that have these odd green stripes appearing in the petals. And that's just white trillium that's been affected or infected by that mycoplasm-like organism. Trout lily, past bloom now, but the mottled coloration of the leaves that's reminiscent of trout would still be present. You see these yellow recurved petals and protruding from them the reddish-orange tipped stamens of the flower. We have two plants with leaves that are similar, but on the false Solomon seal, there's a flower cluster terminating the single stem with branching, alternately arranged leaves. And on the true Solomon seal, there are these paired flowers that hang beneath each of those leaves, right from the axils of those leaves, where they emerge off of the stem of the plant. If it's a plant that looks like the Solomon seal, but it has branches and then the leaves and long dangling yellow flowers, it's bellwort. And my warning, remember when you lay down to take an image, think about what you might be laying down in. Because here I was taking this photograph only to look at the photograph later and see emerging poison ivy leaves. I have to shake my head. Yes, even a botanist is subject to getting poison ivy. Bloodroot, early flower, late April, maybe mid-April, along the edges of these successional hardwood forests, and closely followed by the cutleaf toothwort, very common. These forests I think of as trunk lily and toothwort, bloodroot all being very common, trilliums all being very common in these forests. White baneberry shows up in late May and its fruit by midsummer. The fruit poisonous, white berries with a black dot resembling a pupil, hence its other common name, the doll's eyes. Early meadow, the plants may be male or female. This is a look at a male plant and a close look at a male flower with all of its dangling stamens, the male reproductive structures that release the pollen. But nearby, there could be a female plant that would have more of a capsule-like flower that you would see, small, minute petals that would produce a seed. The rue anemone, a tiny little wildflower of these forests, and an Appalachian wildflower that just occurs in a few areas in our region. Twin leaf, or Jeffersonia Diphyla, one of our few plants is named after one of our presidents. It's got two leaves that look like butterfly wings and a small white flower. It's past flower now, but there's a couple of populations of twin leaf here in Ontario County and a few up in Monroe County. And you certainly could find the leaves of these present throughout the growing season. Blue cohosh is very common in our upland successional forests and also in some of the talus in those ravine forests. And it does produce an inedible blueberry by late summer, but it starts out being very purplish in color. It often grows side by side with mayapple, which protrudes in early May and develops just one umbrella-shaped leaf in its second year of growth, maybe a larger umbrella-shaped leaf, and by its third year, maybe two umbrella-shaped leaves. And at the base of those two leaves, there'll be a single blossom that develops a small golf ball-shaped, pleasant fruit when it's ripe, but usually the fox eat it before us humans can get to it. Back in the pulpit, both male and female plants are prevalent in the successional hardwood forest. Easy one to recognize with its unusual flower, resembling the same flower design of the skunk cabbage you saw earlier. Spring beauties, one of the first things that flowers in the edges of these forests. And in the richer soils of these forests, you might find the Indian cucumber root with its indeed edible rhizome that it grows from buried in the shallow soil beneath the leaf litter. Wild geranium, which even edges out into the open along these forests, and it's in bloom today. I saw lots of it coming here to the field station this afternoon. In the Appalachian oak hickory forests and our drier sites, our sloping sites, look for witch hazel in the fall or shadbush in the springtime. And they really add a splash of color to the shrub layer before the leaves appear in the case of shadbush, or after the leaves have fallen off in the case of the witch hazel. Blueberry in these drier, more acidic sloping forests is the early low upland blueberry. Tiny berries, but the best flavor of all the blueberries, at least that's my opinion. But they're small, and it takes you a long time to pick a quart. We have azaleas that occur in some of these Appalachian oak hickory forests on the shrub layer. We have a perennial evergreen vine that flowers in March. In some of the open areas, it kind of trails or creeps along the ground. It's very, very fragrant, the trailing arbutus. And then poking up in May on the root systems of the oaks is this parasitic plant called squaw root. You may notice that because oaks are so common in this Appalachian oak hickory forest. Flowering dogwoods in bloom as I speak. It's a tall or small tree in the understory layer of these Appalachian oak hickory forests. What you see and think are white petals are actually bracts that subtend the small, tiny flowers that are seen right there at the very center. There's a small grouping of flowers, maybe 20, 25 flowers in the very center. Wild columbine, certainly in bloom now. Watch for hummingbirds visiting it in these Appalachian oak hickory forests. Any kind of open site, trail side, or little clearings, little landslide areas, you may find the native wild columbine growing. Remember the buttercup family. Attica is there as well, with color varying from white to blue to more of a purplish coloration. They're precocious. Their blooms appear before their leaves, and they'll linger as the leaves start to unfurl and develop their three-lobed shape. A-wings, a New York State protected plant, is here in this Appalachian oak hickory forest. And its flowers are irregular and look very moth-like with their unique shape. Painted trillium, wherever you may find acidic soils in the Appalachian oak hickory forest. Some of the sandstone-derived soils at the summit of the Bristol Hills might be a spot you'd look for painted trillium. It also is the common trillium you'd see in the Adirondacks and their acidic soils. Pink ladyslipper, single plants scattered throughout the Appalachian oak hickory forest. It's also known as Moccasin Flower. And unfortunately, it's also known as deer candy. So perhaps all you will see are the basal leaves and what's left of the flower, a clipped off flower stalk, and the blossom's been consumed by the deer population. Wild sarsaparilla with a pleasant drink that can be derived from its root system. It's found in this Appalachian oak hickory forest, and also the star flower in bloom in late May, this time of the year. Both of these would be in bloom. Pussy toads and some of the more open outcrop areas, maybe even some of the chestnut oak dominated communities within the Appalachian oak hickory forests. And there too, you might find the Barren Strawberry with its yellow blossoms and kind of strawberry-like leaves. The toothing pattern is distinctively different. And it does not produce a strawberry-like fruit, dry, seedy fruit that I would not say is palatable. Silverrod, one of our only white goldenrods, and rattlesnake hawkweed in some of these driest of sites, and maybe historically a site where timber rattlesnakes had a hibernacular to get through the winter season throughout the Bristol Hills. Now, finally, we'll end with some successional old field plants. These are more cultural, not so natural habitats. These are abandoned ag fields that are in the earliest stages of succession. And here we do find a strawberry that you can eat, the field strawberry or the wild strawberry. In fact, these may come up in your lawn edges as well. And some of the other more noticeable wildflowers in these sites would include the rough-fruited cinquefoil and, of course, Queen Anne's lace. And it's these sites and these flowers that are very important for our bees and butterflies, especially these two, the butterfly weed and some of these drier old field sites, these sandier soils, and the common milkweed, which can be found throughout our successional fields. And it's so critical for monarchs as a feeding station during their migratory movement through our region. And with that, I'll come to a concluding slide. Thank all of you for participating, and let Allie open this up to questions. Can I hear you, Allie?
Hi, I'm still here.
Thank you. Great.
So Bruce, if you want, you can stop sharing your screen, and then you can also share your video if you want to.
Okay. So if I go to end the slideshow. Okay.
And then on the top of your...
Where it says shared, say stop sharing. And stop sharing. Good. How am I doing? Good?
You're doing great. And
now
if
I
you want to share your video.
I'm start my video, yes. Thank you for walking me through all of this.
No problem.
Did I get it?
There you are. Okay. So,
oh, yes, there I am. I see myself there. Okay. Very good.
So I'll start with the questions that were submitted earlier on. So the first one that I see is, why is Oneida Lake not considered part of the Finger Lakes, and how was it formed?
So Oneida Lake is a very shallow embayment. It was not glacially scoured out like the Finger Lake valleys, or even like Bristol Valley or the Genesee Valley. Oneida Lake was formed as a large embayment along an earlier stage of Lake Ontario that was known as Glacial Lake Iroquois. And some of you may be familiar with Ridge Road that runs through Monroe County and Wayne County. That was the beach for Glacial Lake Iroquois. It was far above the modern beach for Lake Ontario. And Lake Ontario Basin was filled, the northern portion was filled with glacial lakes. There was no drainage through the St. Lawrence Seaway at the time that Glacial Lake Iroquois was there. So it had to drain east, and there was a big embayment that it drained through. That embayment, the relic or remnant of that is Oneida Lake. And just at the eastern end of Oneida Lake, we can find sand dunes that formed at the eastern end of Glacial Lake Iroquois. And this is the Rome Sand Plains natural area that is now owned and protected by the New York State DEC. So it all kind of makes sense. We get sand dunes formed at the windward edge, the eastern edge of Glacial Lake Iroquois, and today along modern-day Lake Ontario.
Okay, wouldn't the Chimney Bluffs and Hamlin Beach State Park bluffs be examples? And they probably were referring to the coastal dunes that you were speaking about.
Yes, but there's no sand involved there. Chimney Bluffs is an eroded drumlin. So after Glacial Lake Iroquois drained away, when the St. Lawrence Seaway opened up, the earliest stage of Lake Ontario was actually lower than the modern stage, because remember, the landscape was depressed by this massive weight of ice. So the St. Lawrence Seaway was lower when it first opened up. And since that time period, the St. Lawrence Seaway has rebounded. Elevationally, it has lifted up to its modern level. So early on, Lake Ontario was much smaller than the one we have today. They call that the Admiralty phase. But as the Seaway bounced back, And Lake Ontario began to grow in size, ultimately about 5,000 years ago, maybe getting to the size it's at today. Those rising water levels ate at the toe of a drumlin that was found there in Wayne County, where Chimney Bluffs is located. So the wave action began to erode the toe of the drumlin, the base of the slope, and the upper slope collapsed as the gravels were washed away by wave action. This exposed those upper soils to wind erosion, so it's very much a badlands-like topography. And at the summit of Chimney Bluffs is actually a wetland, so the summit of the drumlin is a hollow, and that wetland drains and seeps out at the face of the exposed slope. And that water during the winter freezes and thaws and freezes and thaws. So we have this frost action that shapes some of the pinnacles there at Chimney Bluffs to add to the unique formation at the Chimney Bluff site. And over towards Braddock's Bay area, those are gravelly outcrops once again that are eroded by the sinking shoreline of Lake Ontario, because the entire Ontario basin is tilting from the northeast to the southwest in this very, very slow response to the uplifting of the landscape now that the glacial ice has retreated. And it's tilting at about 1/8 of an inch every century. So it's not a major factor, but it's a background condition that affects the shoreline of Lake Ontario.
Okay, let's see. Did flowers evolve features such as landing pads to accommodate pollinators, or were these parts always present?
It was a co-evolutionary process. So the insect pollinators evolved these adaptations as the plants were involving these unique shapes to attract insects for their pollination. Granted, there are wind-pollinated species out there as well, but the question I think was about the coevolution of some of the flowering plants.
Mhm.
Very good question.
Thank you. That was great. Can you give us some advice about being good stewards? Are there plants we can put in our yards that will do more good than harm?
Yes, there certainly are a number of native plants that are commonly available at native plant nurseries that are important for pollinators and serve to attract bees and butterflies and moths. And I would encourage many of those over the use of introduced European species. You can find many native species that are just as beautiful and much more valuable as a nectar source or as a food source for the fruits that they form. Collect from seeds too. You can find very, very easy to germinate seeds, like milkweed seeds.
This is kind of on the same category. Is there a good resource or list of native plants? Does naturalized mean it's safe to plant in my garden?
Yes. There are a couple of resources that come to mind. There's a homeowner's guide to protected native plants. So those are kind of the ones that you would want to avoid. But the level of protection only extends to publicly owned lands. And if it's land you own that has a population and you want to take some of that population and move it to a new location to establish a larger population, that's allowed under the New York State Protected Plant laws. So that's a homeowner's guide to New York State protected plants. It's authored by Don Leopold and Dudley Raynell, who are two professors that I actually worked with when I was a grad student at SUNY ESF. I'm sure there are numerous websites that could give you information on native plants and native nursery seed sources. In our region, there is a Finger Lakes Native Plant Society based in Ithaca, and they would be a good resource. They just had their native plant wildflower sale at the Ithaca, what do they call it? Ithaca, not the Ithaca Mall. Help me here, Allie.
I
The
don't know.
open market, the Ithaca Open Market. Yes, thank you. They just had their sale last weekend. But a lot of garden clubs will be having plant sales, and a lot of them feature native plants that have been propagated safely. Amanda's Garden over in Springwater is another good source for native plants, and she's collected and propagated them in an ethical fashion. And so those are available, and she's very knowledgeable about what plants to put in what conditions and what they look like when they come into bloom, and we'll be attracted to them. But there are many resources out there.
Okay. What conditions make it possible for Honeoye Lake to be polymictal?
Okay, so it's polymictic. Mictic just means mixing. It's an old German word. Poly means many times during the growing season. So many lakes will, over the course of the summer, establish a warm water layer at the top and a cold water layer at the bottom. This is very prevalent in the deeper Finger Lakes, but the shallow ones, the barrier that separates those two layers of water is fairly fragile. If you fish, you know that layer by the name thermocline. So in Honeoye Lake, it has a very weak or a very fragile thermocline, and it's due to the shallow nature of the lake. It's only 30 feet deep. So anytime you put energy to the water column, and that happens when wind blows across the surface, that wind may have enough energy imparted to causing water movement that it breaks up the thermocline and the lake will mix. Now, Canandaigua Lake just mixes in late November and early December. It has a fall mixing when the surface water has cooled down because it's the fall of the year. And colder water is denser and it sinks to the bottom and it mixes the entire water column. But in Honeoye, wind can do it several times. Last year, it only did it twice. Last year, it mixed in May and it mixed in August. 2 years ago, it mixed 7 times. The year before that, I think it mixed 3 times. We have data on this because we've been studying Honeoye Lake for a number of times. And I may not have the number of mixing times quite correct. I know last year it was twice. And within the past 3 years, it's mixed as many as 7 times during the summer. So it's polymictic, but it's not a consistent pattern. It all depends on how windy it is. And that affects the ecology of these lakes. That affects the nutrient availability that is related to the algal blooms that occur in the fall of the year in Honeoye Lake. That's another entire story, much too complicated for now.
Yep, we can have another presentation on that.
Now, we've given presentations on that here at the field station.
Yeah.
When we had in-house presentation, but surely we could give another one too.
Okay, so is the sand at the north end of Canandaigua Lake natural? It seems similar to East Oneida Lake.
Yes, it is natural. If you're up where the water tower is, up on North Street with its intersection with Sand Hill Road, you notice that rolling topography. They're plowed fields right now, and you can just feel the gritty texture of those soils. That's the top of that glacial moraine deposit, one of those recessional moraines. There's a temporary pause in the retreat of the ice margin, and it built up that deposit because materials were melting out at the leading edge of the ice.
Okay, so I think we covered most of the questions. There's a lot of thank yous in here, of course.
Sure, okay.
But I have a question. I was wondering if the early meadow rue was related to the wild columbine, because they look similar.
Yes, they are related. And gosh, I could have mentioned the silver maple ash swamp here has a meadow rue that's characteristic of it. And that's the tall meadow rue. That'll be blooming in early summer. And Ellie, that one gets about 6 feet high, whereas the early meadow rue in the upland soils is only about 2 feet high.
Okay, you might have pointed that out to me at some point, but I'll have to
I will
revisit
surely
that.
take you out there. We'll do a swamp stomp out there and enjoy it again.
That sounds great. All right, well, I think that's the end. Thank you everybody for coming. Please stay tuned for more information on our next Speaking of Nature in June. Just give us a follow on Facebook and Instagram and check out our YouTube channel. Thank you so much, Bruce. That was
You're
great.
welcome. Bye, everyone.